All right, let's take a look at objective number 3 of lesson 6.1. What is a sampling distribution? Objective number 3 is using the sampling distribution of a statistic to evaluate a claim about a population parameter. So when the question is asking you, to evaluate a claim about a population parameter based on the sampling distribution of a statistic, there are three steps. First, you assume that the claim is true, and then we can either prove or disprove this claim. Second, you create a simulated sampling distribution. Almost always, the simulated sampling distribution, especially if it includes very large samples, okay, is already given to you. Now, the third one, step number 3, is we will find the percent chance, the probability of getting the observed result based on the sampling distribution that we have created in number 2. Now, if the percent chance, if the probability is less than 5%, then there is a convincing evidence against the claim. The claim is not true. We cannot accept the claim. Okay? If the probability is greater than or equal to 5%, it means that there is not a convincing evidence against the claim. The claim can be true. And we got the sample statistic by chance alone. So let's take a look at this example. At the beginning of class, Mrs. Chauvet shows her class a box filled with black and white beads. She claims that the proportion of black beads in the box is P equals 0.50, meaning 50% are black beads and 50% are white beads. To determine the number of homework exercises she will assign that evening, she invites a student to select a simple random survey of n equals 30 beads from the box. The number of black beads selected will be the number of homework exercises assigned. When the student selects 19 black beads, in which case the proportion of that sample is 19 out of 30, which is equal to 0.63, the students groan and suggest that Mrs. Chauvet included more than 50% black beads in the box. So the student, Mrs. Chauvet was claiming that it's 50-50, 50% black beads, 50% white beads. And the students were now saying that there might be more black beads in the box than white beads. To determine if the sample proportion of p hat equals 0.63 provides convincing evidence that Mrs. Chauvet cheated, the class simulated 100 SRS of size n equals 30, assuming that she was telling the truth. That is, they sampled from a population with 50 black beads. For each sample, they recorded the sample proportion of black beads, and the results of the simulation are shown on the next page. So here is the result of the simulation. Okay, let's answer these questions. So number 1, there is one dot on the graph at p hat equals 0.77 right here. Okay, there's one dot. What does this dot represent? Now we know that there are 100 dots here to indicate one simulation, one sampling. Okay, so we can say that that 0.77 in the graph indicates that in one SRS, in one simple random sample of size n equals 30, say that 77% of the beads were black. Okay. Now, letter B. Would it be unusual to get a sample proportion of 0.63 or higher in a sample size of 30 when P is equal to 0.50? Okay, so let's take a look back at the three steps. First, we assume that the claim is true. Okay, so we assume that the claim is true, meaning the proportion of the population is 50%. 50% black beads, 50% white beads. Second, we have the simulated sampling distribution. Okay, now the third one, we have to calculate the probability. So we want to find the probability that we will get a sample proportion of 60 or higher. So let's write it down in notation. So the probability that the population proportion is greater than or equal to 0.63. So in this case, we are looking, this looks like this is your 0.63 right here. Okay, so we're looking at this lot. That's your 63 or 0.63 or higher. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability would be 9 out of 100 SRS, which is equal to 9%. Okay, so is it unusual? We say no. Okay, so based on our answer to part B, is there a convincing evidence that Mrs. Chauvet lied about the contents in the box? We say no. We can accept the claim as true because 9% is greater than 5%. Okay? So we say no because the probability from part B is greater than 5%. So that means it is possible, plausible that the proportion, and this is what the claim was, that the proportion of black beads is P equals 0.50, as Mrs. Chauvet claimed. Okay? And we can add in that this student that she selected, the student got a sample proportion of p hat equals 0.63 by chance, alone. And it is not because there are more black beads than white beads.